Hello, I hope you're all doing well and welcome to another video. So I thought today we'd just take a look through this test equipment which I was recently donated to me by someone of the name of Dave. So if you're watching, Dave, hello, and it's much appreciated. There's quite a bit here, some really good stuff here, some stuff that's going to be very useful for me. And I thought today we'd just go through it, take a look. We're not going to do any deep dives or anything. I'm not going to, strip anything apart really. Might take a look inside some stuff, but I've tested most of this stuff, and some stuff I've not really tested. So we're just going to take a look at it, see what there is. Okay, so the first thing we'll take a look at is this Variac. So, and you'll have to excuse the camera angle. This is the best I can really get for showing this stuff off. So this is a Variac, and it's quite a nice Variac. It's all metal cased, quite small and not too heavy. I do have a Variac already, and you may have seen it in a previous video. Can't remember what the brand was. I think it was Bronson. I think it's like a German brand, and that's quite a nice Variac because it's 1000 watt, so it's quite a beefy one, and it does have a digital voltmeter at the front, which is nice. But this one I think is going to be my main one from now on, just because it's lighter and smaller, and it's quite nice because it does have an amp meter, a current meter there, so that's quite nice. But yeah, we got the input there, the output, and the on and off switch. Of course, you have to be careful with analog meters like this, because especially with something like this that's supplying mains, you have to just make sure it's accurate enough. So I have tested it and it is accurate, which is nice. It does go, well, the meter goes up to 300 volts, but it only goes up to, I think, 270. If you look at the back here. So yeah, it is a Farnell Variac. A few of these things are from Farnell, and I think this is from early 2000s, late 90s, early 2000s, something like that. But yeah, it's quite a nice one. Okay, and this heavy one is a power supply, a bench power supply. And some of you may recognize this because it's a fairly common bench power supply. I think these were originally introduced in maybe the late 70s, early 80s. And it's a Farnell one. It's LT30-2. And yeah, it's a dual power supply. It's got two, and they're both 30 volts at 2 amps. And you can put them in series to get 60 volts. But yeah, these are fairly decent power supplies. I do have one of these already, actually. But the one I have is in pretty rough shape, and also the right meter doesn't work, and the left one is inaccurate. So, of course, I can probably fix it up at some point, but this one's in really nice shape, and it is all working well. So this will replace the one I've got, because I don't actually have many bench power supplies, to be honest. So this will come in handy for sure. And then we have some bench multimeters here. So I've always kind of wanted some bench multimeters, but yeah, just never picked any up. So these, I think, are from sort of early 2000s, late 90s time, and they do stack quite well. But yeah, they are the GW GDM 8135. And yeah, it is a typical multimeter, pretty much. Has continuity test with a beep as well, which is nice. But yes, these do work, but one of them, I can't remember which one. But one of these, the speaker for the sort of continuity test and stuff like that, doesn't work. So that's the only fault with one of them. I believe that's quite a common fault as well. I've seen it online. A few people have issues with the speaker. Now this one will come in quite useful. And to be honest, a lot of this equipment I would really like to have above my workbench. So for example, right now I have these compartments for some capacitors and resistors, but it would be nice to have above my workbench some shelves, some heavy duty shelves. Then I can stack equipment like this and like the digital bench multimeters. What's cool about this is that you can see the voltage, the current, and also the power of any device you're powering, basically. So this goes in between the main supply and the device that you're testing. So the main supply would go in here, the 240 volts, and then the output would go to the device under test. And what's useful about this is, of course, if you're powering something up, an old piece of kit, you can see how much current it's drawing. So obviously, if it's, there could be a short if it's drawing too much current. Quite a useful device, definitely something I will use eventually. But yes, quite a useful device. So I can see how much current I'm drawing. So this is something I do want to eventually, I don't have the space on this desk, but eventually I'll set it up as like something that's always there. So I can monitor the current, but actually it will be useful for the voltage too, because if I'm using a Variac, like the analog Variac I showed at the start of the video, I'll actually be able to monitor it so I can be extra sure that the voltage is correct. And then at the back we do have some interface connections. So we have a serial one here and a USB. So I'm assuming you can maybe you can monitor the voltage, current and power from a PC and have it on a display. That'd be pretty cool. That might be quite useful for a live stream. I have thought about doing a live stream. And if I can hook this up to the PC, up to my computer up here, I might be able to have an on-screen display on the live stream showing what this is displaying. And I almost forgot to mention, this is the cable that it came with. So you put that into the mains and you hook up the connections to the meter, and then you have the output go to this IEC cable. Right, so I'm going to show these together. Now these are fairly old pieces of kit. Again, I think late 70s, early 80s. This one is a WaveTech 4 megahertz function generator, model 182A. Yeah, and this one can do, as it says, 4 megahertz down to 1 hertz, I guess. And then we also have this, which is a Farnell piece of kit as well. This is a sine and square wave oscillator, LFM4, 10 hertz to 1 megahertz. This one's interesting because it can actually be powered by battery. But yeah, very nice condition this is in. And we'll test these out now with another device. This is a Fluke 1900A frequency counter. So I believe this is one of the last Fluke frequency counters that was actually made by Fluke. I think after this, they got another company to make them and then they rebadged them. Yeah, this is a nice little Fluke one. I think this is from like 76. So it's quite old. But yeah, it does work fine. So we'll test it with these two. Okay, so to test these, I thought we could use the oscilloscope and the frequency counter. Now the cool thing about this Hitachi oscilloscope here is that the channel 1 input essentially passes through the back and you have a channel 1 output on the back, which I'm feeding to the frequency counter. So we can plug these in here and we will see it on the oscilloscope and the frequency counter. Okay, so this Farnell here, this LFM4, just has these banana jacks for output, not any BNC. So what I'll do is I'll just hook up some croc clips to these and hook it up to this probe. Okay, so I'll hook these up That one doesn't like to go in fully, but it should be okay. And I'll hook these up to the probe. Okay, so I've got it hooked up here to the oscilloscope probe, and then we'll turn it on. So now it's on. Let's see, we'll set it to, okay, so I've got it set to 1K, and it's on 9, so it should be around 9 kilohertz. And I've got it set to square wave. Okay, and as you can see, we've got 9 kilohertz, and we've got a square wave here coming into channel 1. And I can switch it to a sine wave. And I'll adjust this to 11, which should be 11 kilohertz, or around that. Yeah, so it's 10.4 there. So, okay, so this is 100 kilohertz sine wave. And I can change the amplitude. So if I set this to 6, so I can change the amplitude here. So if I set it to, let's see, so that's 4 volts peak to peak. So yeah, 4 volts peak to peak at 100 kilohertz. And there we go, 102 kilohertz on the frequency counter. We're set to 1 volt per division, and we've got 4 divisions. So yeah, we're looking good. We've got a signal generator here, quite a fancy high-end one, and there is another one as well, another HP one, which I'll show you after this, but this is a Gigatronics 6100, and I thought this was later than it is. I thought this was like 2005, something like that. It's actually from 1992, at least that's what I could find online. I was looking for a manual for this, but I can't seem to find one. The only thing I could see was like a photo of some old eBay listing that was showing off the manual, and it said the print date of the service manual was 1992. So it's at least 1992 when this thing came out. But yeah, it's quite a nice signal generator. So I believe the lowest it can do is 10 megahertz. And I think it goes up to 8 gigahertz, I think. And one nice thing about this is that it's not as heavy as the HP signal generator, which I'll show you after this. It's not as heavy as that one. It's a lot lighter, a lot easier to move around. Yeah, this one's a lot lighter, a lot easier to move around. It has a stand as well, which is pretty nice. Okay, and we'll power it on. I've already got mains hooked up. We have a standby light. Then I'll press power. And there we go. It's very loud. You probably won't be able to hear it that much with my microphone, but yeah, it's very loud, and it's set to 10 megahertz, which is the lowest it will go. And yeah, I think it goes up to 8 gigahertz, I think. Oh, it seems to go up to 9 gigahertz. I did just do a quick check, and it does say it only goes up to 8 gigahertz online. So I'm assuming that's just, you know, not the super accurate 9 gigahertz. I guess it's just, it can do it, but it's not in the specification. But it doesn't seem to go any higher than that. Oh, it does go to 10 gigahertz. 11. Oops. 12, 13. Okay. 12.1. Okay, so it goes to 12 gigahertz. Okay, so it seems to go to 12 gigahertz, which is a surprise. But it won't go any higher than that. No, just 12 gigahertz. And yeah, the lowest it'll go is 10 megahertz, I believe. Yeah, 10 megahertz is the lowest. Okay, I've got the frequency counter hooked up, so in theory, if we turn the output on, yeah, we get 10 megahertz. So let me check. 12 gigahertz. Yeah, so it will output 12 gigahertz. But yeah, 10 megahertz there. We can adjust this on the fly. And yeah, it's pretty accurate. I mean, it's pretty solid. That's too high for this. This only goes up to 80 megahertz. So that's 80 megahertz, 70, 50. Let's just do a random 56. Yeah. I'd say that's pretty accurate there. And I believe this has a sweep as well. You can do a sweep with this. And I think it has markers, but I don't know how to use it. And again, I don't have the manual, so it'll be something I have to figure out in time. This here is quite a very high-end signal generator from the 80s. This one was originally released in 1984, so quite an old one. But yeah, it was very expensive at the time, and it was high-end, pretty much one of the best you could really get, I guess, for signal generators. It's a 8642B, and it goes from 0.1 to 2100 megahertz, so 10 kilohertz to 2.1 gigahertz. And yeah, this thing is a beast. I think it weighs like 31 or 35 kilos, I think. Something like that. It weighs a lot, basically. What was nice is that I actually found a physical manual for this. And it's quite a beefy one. And this is just for the operations, nothing else. There's no schematics in this. This is all just to operate the signal generator. A nice brochure at the front as well. Now there is a video on YouTube of this one, sort of a video like a advertising video. I guess it was sent to companies to see if they were interested in purchasing this signal generator. And I believe the YouTube account, video99.co.uk, I believe it is, has uploaded a video. I think it was on an old Betamax tape. Anyway, he uploaded that. It's from 1984, and it talks about this signal generator, and it's a pretty cool video. But anyway, let's power it up. It has its own boot process. Okay, so let's power it on. Okay, so maybe you heard all those clicking relays, but it does a little self-check, reports if there's any errors, any issues, and there isn't any. There's also a message button, so you can check any error messages or anything like that. It's showing 100 megahertz right now. Yeah, it has this backlit orange display. I think the earlier ones had this sort of orange display or amber or whatever. And I think the later ones had like a white backlit display. Right now I've got it set to 2 megahertz. And it's been outputted to the frequency counter. There we go, 2 megahertz. And if I adjust this, if I can figure out how to do it. There we go, frequency, change that, and it changes this. Also, this one I can see there's a sweep function. I don't think there's any markers on this generator. But if we start the sweep frequency, I'll set it to, let's go to 4 megahertz. And the stop frequency, let's say 8 megahertz. Okay. Yeah, and that's it sweeping. So yeah, I haven't had a chance to fully test this yet, but it seems to at least be doing what it should at the moment. But of course, this is very something like this takes a lot to learn, especially with the size of the operations manual. But this one is so heavy and so big that I am going to keep it because this is something I really want to use in the future. But for now, until I get the space, I'm just going to use the Gigatronics signal generator rather than this one. But this one yeah, very nice one to have. Another thing I noticed is that the HP logo is upside down. I don't know why, and I don't know if this comes off. I don't want to break it. I don't want to damage it, but yeah, upside down HP logo. The last thing to take a look at are these spectrum analyzers, these HP spectrum analyzers. I did not think I would be getting a spectrum analyzer, at least not for a very long time, because as most of you know, spectrum analyzers are very expensive. Even old ones like these are actually from, well, they were released in 1989, so late 80s, and this one is a 8563A, which is 9 kilohertz to 22 gigahertz, and then we've got a 8560A, which is 50 hertz to 2.9 gigahertz. Now, I don't have a massive use for a spectrum analyzer at the moment. Well, there is something that I could use it for, which is IF alignment, because this one at the bottom has a tracking generator on this output here. So this could actually be really useful for IF alignment of TV sets. But I will definitely have a use for these in the future. And I haven't had a whole lot of time to figure these out yet, but we'll turn them both on here. So I think these date from 1992, these particular ones. But like I said, these were released in 89. So yeah, it isn't flickering like it is on the camera. But yeah, right now it does a boot up process. Okay, and they are both booted up now. As I said, this flickering isn't like this in person. But yeah, copyright date of 1989 on both of them. But I think if we go to, where is it? If we go to config, date code and options, yeah, this one, yeah, I believe they're both from 1992. They got the same ROM revision as well. But yes, definitely have use for this one with the tracking generator. I'm sure I will find use for these anyway. These are very nice to have, and especially older spectrum analyzers. Like, I love test equipment from the 80s and 90s and earlier. But yeah, I haven't had a whole lot of time to play around with these. I'm considering getting an active probe, which I believe uses the probe power socket here. I don't have an active probe, and an active probe is very expensive. I think you can make your own. I mean, like an RF probe, you know, RF active probe or whatever. I don't know, there's a whole world of probes for spectrum analyzers. I think you can use an oscilloscope probe, but it's not ideal because of the impedance and the load it will put on a circuit. I think it depends what circuit you're probing. I'm not sure for IF alignment if I could use an oscilloscope probe. Maybe anyone watching can let me know. But it's something to think about for the future, so I'll need to sort out some sort of probe. But yes, you may see these, or at least one of them, in a future video. But yeah, anyway, that is it for the video. This was just a brief look at this test equipment, which you will hopefully see in some future videos. But yeah, I do appreciate you all watching. I hope you all have a good day, and take care.